In an experiment to study collisions, block A of mass m1 is moving with speed v0 when it collides with block B of mass m2, which is initially at rest. After the collision, the blocks stick together and move off with speed vf. For a series of collisions, block A is given different values v naught. The graph of Vf as a function of V naught is shown. How would doubling mass m1 change the graph? From conservation of momentum, we have that m1 V naught is equal to m1 plus m2 times Vf. Therefore, Vf is equal to m1 over m1 plus m2 times v naught. Not surprisingly, the graph should be linear, and the slope is the ratio m1 over m1 plus m2. In order to determine the effect of doubling m1, we could start by writing the slope as 1 over 1 plus m2 over m1. If we now double m1, clearly the ratio m2 over m1 is reduced. Therefore, the denominator of the slope is less, and the total ratio increases. This means that the slope of the line is greater, which corresponds to option B.